Today's conversation is with Sergey Gorbunov, the CEO and co-founder of Axelar. Axelar has raised over $68 million at over $1 billion valuation, building the universal overlay network, delivering secure cross-chain communication standards for Web3. So they effectively help the different protocols in Web3 communicate better. They're acting as the underlying network between them. We talked about a few examples of that: general messaging, general message passing, what that means, how the impact to a consumer or an investor using these cryptocurrencies would be improved from the Axelar network. We talked about Sergey's background. He had previously been at MIT, Waterloo, and University of Toronto, got his Ph.D. and studied cryptography. So we talked about academia, the role of academia in cryptocurrency and the development of the ecosystem. We talked about the future and impacts of DeFi and NFTs and what the future experience would look like in the not too distant future for a Web3 user. Lastly, we talked about the structure of the company versus the foundation, where the 68 million went, how they fund development for the protocol while being a separate entity. And we talked about the pros and cons and the differences of the foundation versus the company structure. So hope you enjoyed this conversation. It was technical at parts, but overall not too bad. Here is Sergey Gorbunov. All right, Sergey, I'm excited to chat with you. Yeah, let's cover our bases here. So you run an exciting project called Axelar. How do you say it? Do you put the emphasis on Axelar or Axelar?
Axelar, yeah, that's right.
Yeah, okay, we'll start there. Maybe just to set the foundation here for the conversation. What was the impetus for the project? Did you realize a specific problem when you were at or other folks in the team working at Algorand? How do you sort of lay out the projects that sit next to Axelar and why this is exciting to you to work on? Yeah,
I mean, so prior to Axelar, I was working on a project called Algorand, which is a proof of stake blockchain that we designed and took to the market with a team out of Boston. And kind of after launching it, we had an immediate need for connecting Algorand with other ecosystems. Wasn't really clear how to do it at all. Not that you could call any provider, not that you can just take any protocol and plug and play. So kind of all the solutions that were available to us didn't really work, or would require like heavy engineering resources to be invested, for a couple of years to kind of integrate them. So pretty bad approaches. And then what we realized that there's going to be a need for seamless cross-chain communication, right? Mm-hmm. Seamless, secure, easy to use, and easy to navigate. And, kind of decided to focus on that problem with my co-founder, Yorgos. And since then been tackling that in the kind of a high level, right? As you see the ecosystem, there's just so many different blockchains, different consensus mechanisms, different, smart contract languages, and so on and so forth. And communication between them has been full of bugs, vulnerabilities, and friction. And so that's what we're trying to eliminate.
How was it obvious to you at that time that this was the solution to the problem?
I mean, I think, it's not kind of an overnight thing, right? With, heavy engineering projects like this, you go back to the basics. My kind of a deep roots a while back date to working on things like software-defined networking, where we actually thought about like how do you make very efficient, very scalable software-defined networks that allow efficient communication across different environments. So those really, really, really fun projects where you actually, you don't talk about 5 or 10 minute blocks. You talk about, nanoseconds, microsecond latencies, right? And like you building a kind of a system to optimize for that. So, in the blockchain, we're talking about 1 second block. It's like an achievement. Yeah, so kind of kind of going back to some of those academic works that we did and projects that we worked on, just understand what makes a good cross-chain communication system, what properties does it have to have, and those properties are not new, right? There are properties in computer networking and database systems that have been defined for the last 20 or 30 years that work really well to scale, that people have iterated. And then you understand, okay, given those properties like plug and play connectivity, right, like asynchronous communication and so on and so forth, how do you apply them in this blockchain domain now, right? What they actually mean? What does it look like? How would the system look like that would have those properties? So I've been kind of iterating, right, with the designs, and kind of eventually settled on something that was pretty convinced would work. It was really quite interesting where kind of pick the design, we pick the architecture and the software stack to start with. But I think even a lot of early engineers, were still not quite sure, right, is it going to work or not. And I remember one of our core engineers, maybe about 8 or 10 months in the development when everything was actually working and like the packets were flowing from one network to another. He was like, "Oh, this actually works."
It is.
So it's been amazing.
And you mentioned the academic background. I think we're at Waterloo, MIT, and University of Toronto. Of the different places that you studied and worked, which did you learn the most from? And then what is the environment like in academia? I mean, you just, at the time, I would imagine, weren't specifically thinking about building on blockchain and Web3. It just kind of evolved that way, that this kind of exploded at that time. What's the scene like then versus now? Is it like, are programs being flooded with students because of the popularity of different cryptocurrencies and projects? Like, help me understand, like, where's academia in all this?
Yeah, no, great question. So I think academia, I guess I would divide between, let's say, 2 buckets, right? You have your students, which are mostly like undergraduate students, right? Sometimes that are there to kind of learn, right, to get into a field, one field or the other, right? Or just learn their basics, right? So you have undergraduate, master's degrees at some universities. And then you have kind of research academia, right? And research academia is where, academics like look at specific problems and things like that. And so those 2 different buckets are always at different phases, I would say, right? When it comes to kind of technology adoption. So on the academic side, the concept around blockchain payments and things like that's been, in the works in various protocols, the themes for the last, 30, 40 years, right? You had electronic cash payments, kind of a dated many, many years ago, and things like that. And, was largely, I would say, dried out field until, Nakamoto, until Bitcoin, until Ethereum. And I would say, kind of when academics just realize some of those issues that, or some of those solutions, right, and like how they address it, and they created, new sets of problems. And then there was a flood of academic research in, I would say, 2016 to 2019, 2020, right, where a lot of academic research were like, oh, by the way, there was, Ethereum, or there's Bitcoin that has problem X, Y, and Z. Let me show you how to solve problem X, Y, Z, or, let me propose a modification, extension of the system. So definitely there was like a 4 or 5 years of just opportunities for academics to write papers that they can also say, by the way, this is practical, this is relevant, you can go, you can like apply it as, and you had code that you can then clone, modify, and show how, your improvements or your ideas would work, right? So there was like an area of excitement. Many publications were produced in the time. And I would say over the last like year, maybe even 2 years, kind of that excitement a bit dropped, right? Like I think all the low-hanging fruits were picked off. All the papers were published that could have been published. And I would say now we're in a position where the industry is leading a lot of research, leading a lot of innovation in the space. It's not just about a theoretical problem anymore. There's a lot of kind of complex engineering, a lot of complex scalability problems that need to be solved. And academics, A, maybe they're not as interested in that, and B, they don't have resources, and so they have other priorities, right, and like other types of work to focus on. So from a research perspective, I would say kind of last 2 years, it's kind of cooled off a little bit. So that's one bucket, right? Sort of research, and that's a cycle it has gone through. And then you have students, and I would say students are like applying, to do studies in one field or the other. Definitely 2018, 2019, 2020, a lot of interest from students wanting to learn blockchain technologies, right? You had first universities that started to introduce blockchain courses, Stanford, right? I mean, we didn't have an explicit course at Waterloo, but I taught, some parts of it and graduate courses there. Then, I think MIT had, Bitcoin courses, part of their Sloan program as well. So definitely a lot of interest from the students. Now it's still high, I would say, right? Maybe not as high as it was, kind of a year and a half ago, but I would say still pretty high, interest from the students. You definitely understand a little bit more who is serious, who is not, right? Because students, especially the ones that apply for undergrad, they hear buzzwords and they think, that's the way to do it. And now you definitely get to see which ones are, there because they actually understand and actually want to learn it versus just, hearing buzzwords. So yeah, that's kind of on the undergraduate cycle. On the undergraduate cycle, I would say like there's definitely just huge opportunity to educate students with the right tools, with how to code in these environments, how to develop, how do you scale your products around applications built in blockchain environments. It's completely untapped, I would say, right now, like very early roots. Some individual academics are doing at a few places, but I see like as a huge opportunity to help students kind of prepare and get into the industry once they graduate.
Yeah, it seems from the outside like it's been a successful passing of the baton, like a successful pathway from academia into industry. If you had to give a grade, like a letter grade, to the effectiveness of the funding that went into academia for the purpose of crypto and the output of that and benefits to society, where would you put that? I've heard a lot of criticism on funding and research grants and how that whole system works, but I'm curious how you assess the health of the ecosystem.
Yeah, great question. So I don't think that much funding went into academics doing research on these things. I would, I don't have the numbers, by the way, so I may be completely off here. But, I would definitely say that kind of academics that I know that were writing grants, maybe they mentioned some blockchain, right? Or maybe it's a part of their theme. It's not that you had kind of tens of millions of dollars as we see for other programs, right? Fund any given project. I may be wrong, but, mostly it's like smaller amounts, here and there. So what came out of that? Okay. So what came out, depends, right? Like you definitely have a couple, I guess, companies, right, that were led by directly or indirectly by, folks with deep academic backgrounds, right? Some maybe they already left universities at that time, right? Some maybe they were kind of incubating. So I guess, Avalanche, right, definitely has strong affiliation with Cornell. I mean, I don't know if they were still a part of the university when they were doing it, but, definitely strong affiliation. Starkware, right? I think, from Israel, right? And Technion, I believe. So strong affiliation, Algorand, we're all kind of graduates of MIT, right? And kind of Sylvia was a faculty there before starting. So there are some that have ended up being, pretty successful, right? And kind of continue to build. There's some that didn't go that far, right? So I think, let's see, what are good examples? Yeah, I mean, can't remember all of them, but I definitely think there's a couple that didn't make it.
Yeah, it's interesting. It feels like in my lifetime, it's the closest. I say this: it's the closest large industrial boom that has been the closest to academia. Like if I think of where has academia and industry been really close in partnership, I think about like I think of not necessarily academia, but government funding of research, like space travel for sure, the development of the internet for sure. Like when I think of genomics research and a lot of that work, like deep tech work. But this is interesting because it's like it almost took the thought process of academia with the white paper and the way that the layer one protocols are effectively designed and communicated. And it just that became the default way to communicate these things. And so people very much who never read an academic paper in their life or never thought that this would be, when you launch a product, you typically launch a product that people can use. Now you're launching an academic paper or white paper. And it's kind of interesting to see the culture of academia being just largely disseminated across society, which I think is exciting. It's really interesting to see the level of sophistication of the average person being up-leveled in some way due to this.
Yeah, no, for sure.
Did you want to add anything to that?
Yeah, no, just I guess even like the notion of, like you mentioned, like white paper, right? Yeah, I mean, it's a bit of a danger, right, with some of this stuff where some people, like I've definitely seen, some people get the space to be like pretending to be like pseudo academics, right?
Right.
Because it's a white paper, it doesn't mean it's academic, right? Like academic papers by default go through deep peer review process and probably a year or two of thinking behind the scenes at the very least, right, to kind of come up with something. And just because I remember actually Kristen Catalini taught a lecture at MIT, right, and he did some early research about how projects are getting funded, what is their state, like, do they have GitHub code, do they have white papers, right? And he was like, the number one qualification that you should apply as a filter is to check whether or not the paper was written in Word versus LaTeX. Because if it's in Word, academics don't write in Word, it has to be in LaTeX. So like, if it's not in LaTeX,
that's funny.
Like, ignore it. Like,
and can you check that? Is there a way can you look at it in like the syntax or the font can you look at a PDF white paper and backtrace that?
So I'm pretty sure like something in the fingerprint of the white paper, you can sometimes detect. The style, the fonts are very different. I think most academics will tell you right away whether or not something came from LaTeX.
It's interesting.
Versus Word.
I had not heard that, but I definitely can see that being true. And also there's so few people who can, this is largely the criticism that that played out to be a real concern, which is that the average person can't look at a white paper with deep math on it and tell 2 from 2. It's like you can look at it and be impressed by it, like you would a work of art or a piece of music, but you can't disseminate any logical conclusion as to the validity or the integrity of the research. That's where, I think the cart gets ahead of the horse. But it's interesting. Yeah.
I mean, on that, right? Like, I think most people can't validate most other people's work. It's not just, not just regular people.
Yeah.
Like even in academia, I think one of the biggest problems now is just the sheer volume of stuff and the length and complexity of things that makes it incredibly challenging to do validation, right? Like cryptography papers from 20 years ago were 8 pages, 12 pages, 15 pages, right? Like now cryptography paper is like 40 pages, 45, 50 pages. The math is like incredibly more complex, but you still have like, 3 or 4 reviewers that are on it. Now these reviewers are a lot busier with the volume of stuff in academia. And there's like 45-page paper, like with deep math that you have to, spend like weeks studying if you want to actually truly validate it. And I think very few papers actually end up being validated end to end, even by academics. So yeah, maybe we need some good AI or machine learning.
Let me ask you this. Like I've heard you say in a previous interview that you really try, I think it was something you wrote or something you interviewed. You were talking about the simplicity in which you intentionally designed Axelar, and that there's a beauty in simplicity. There's a strength in simplicity. when you see a paper that's 45 pages in length, does that throw up a yellow flag or red flag to say, hey, this is probably way over complex and high risk because of that?
I mean, not necessarily. I mean, I wouldn't say necessarily like the length, right, and the simplicity, they're correlated. They're not direct, consequences of one another. So you definitely have 45-page papers where, let's say, like you can have a core idea that's sort of simple and can be explained, in one sentence, right, or one word or one formula. And then maybe you have more complicated proofs behind it, and you can still have intuition that's communicated that can be quickly verified by other people, right? And then you can have, more detailed proof that need to be maybe kind of checked with a magnifying glass. And vice versa. You can have, I read some blockchain papers, by the way, right? And then, they could be 6 or 7 pages. It's like nonsense because like they're full of formulas that make no sense, like no intuition, no understanding. Like sometimes I get an email and like, what do you think about this? I'm like, okay, I don't want to think about this.
Yeah, totally.
So yeah, I think
how do you?
Yeah. So just the last thing, I think simplicity is really something you have to build, right, as an engineer, as a human being, right, and think about like what is simple, right, like how do you define simple, how do you always strike towards simplicity, and like it goes not just at the code complexity, white papers, it has to be all the way up to the stack, to the UI, right, to the tools that we're using, to how we interact with one another, because I think just overall complexity in the world keeps increasing, and I think understanding as a result not necessarily goes up.
Is there an example of a challenge or a design decision or constraint at Axelar where you consciously made it simpler? Like, could you paint this a little more by saying, okay, we were deciding between these two infrastructural design methods, and I'm curious to hear if anything comes to mind.
Yeah, no, great question. So let me think about some of this stuff. Yeah, I mean, I don't remember, at what point, but here's like one concrete decision. So in Axelar, Axelar validators, they monitor other blockchains, right? And so they monitor what we call as like gateways or routers, right? So you have a router at home, right? And whenever, you're sending messages from your home internet computer to this router, some protocol, takes those messages and then routes them somewhere else and delivers them, right? So that's what gives you kind of connectivity from your home to the rest of it. So analogously in Axelar, we have Axelar validators that are monitoring these smart contracts or gateways that act as routers on different chains. And when information comes in, they validate it. And so one, important design decision was that, well, who is going to be relaying packets from those external networks to the Axelar validators to ask them to validate it, right? So one, you can say, well, maybe the validators themselves just, observe individually each one of these routers, right? That's one way of doing it. And another way of doing it, which is kind of the right way, which we ended up with, is by saying, well, anybody can actually observe messages to those routers and then tell them to the validators, and then validators will only need to say yes or no. Are those messages kind of authentic? Are they valid? And if yes, then they would kind of run a consensus to finalize those messages, right? So kind of the concept of delivering the message versus validation of the message is actually quite important to keep decoupled, because you have very different properties that you require from delivery versus validation, right? So, think about analogously kind of you have transportation systems like, airplanes, right? You come in by an airplane to a country, and then you have a border control agent, right, that sits there and sort of verifies your passport to let you into the country, right? Delivery of you through an airplane is handled by, one company, right, and one operation. And that's purely a process of making sure you get there on time, right, and making sure But then the entrance is sort of enforced by a second layer of verifications that through the border control that has very different requirements, right? That has very different sets of checks beyond just did you pay your airfare or not, right? And so similarly, like in Axelar, I think decoupling those building blocks and making sure the system is modular is really something, important that has better properties at the end of the day.
Okay, that's a good answer. And how do you articulate the benefit to the ecosystem, or what layer or who benefits the most from Axelar? And like, how does the economics sort of work?
Yeah, at the end of the day, who benefits are the users. Okay. Why? Let me tell you. So right now, if you interact with multiple blockchain ecosystems in the space, it's horrible. Right. You have to interact with multiple wallets. You have to have gas paid on multiple chains, maybe use like some bridging protocols to go back and forth, maybe using some exchange to swap one token for another, just so you can pay the gas. Right. So like the process of interacting across applications in the blockchain environment is just very, very, very much full of friction. Right. So that's one point. Two, it has very big economical implications. Right. So as an example, one of our backers, Steve McKean from Collaborative Currency, they wrote a blog post describing what happens with asset fragmentation when the assets are split across multiple AMMs in different blockchains. If you can't unite liquidity and have universal liquidity that's accessible everywhere, you end up splitting it and fragmenting it. When you split and fragment it, it means the users that are doing their swaps effectively end up paying more. Right, because there's not enough liquidity, the pools are smaller, and so you have naturally more slippage. So that's a very practical economic impact, for the users, right? So there's UX, there's an economical, aspect, and the third of it is actually scalability of the systems, right? Every time we're seeing a growth in one ecosystem or the other, we end up with a lot of congestion on the network. We end up with very high transaction fees, right? On Ethereum, on other newer chains, we have seen it as well. And users have to end up paying more. They have to wait longer latency and so on and so forth, right? And so by connecting then different blockchains in a universal way, what do you enable? You enable simple interactions where as a user, you have a wallet, you see an application, you just go and use it. You don't have to think about which chain is it on, how do I move to that chain, how do I pay gas on that chain, and like all that complexity is sort of eliminated, right? So it's super important. I think like Web 2 experience is much simpler than Web 3 experience right now. And if we want to continue showing the benefits of this ecosystem to other people that are outside of the ecosystem, we have to simplify the UX and the experiences. So that's one. And then second point is for liquidity, which I already mentioned. Once you unify liquidity, you can have much more efficient economic models where the users, at the end of the day, when they do a swap from one asset to another, just end up paying less. So period, as simple as that. And finally, you have scalability that can be solved, right? Where as a developer now, I can say, okay, for my application, I actually need to host it on this chain, because it doesn't have a lot of other applications and has very fast finality, it has low gas costs and so on and so forth. But I'm still connected to everything else and everyone else in the ecosystem to interact with my application, right? And so as I scale my application, my resource environment is still isolated, so I can offer really good quality of service for my users at the end of the day, right? And don't have to compete with Uniswap or other, SushiSwap doing airdrops or anything like that on the same network at the hour when I'm trying to launch my product. So very direct, like technical, scalability things that can be solved by allowing the system to sort of scale across multiple chains.
So yeah, price and liquidity, really. I mean, effectively, if you boil down to the benefits of the consumer, because these layer ones are connected, people benefit, right, with price and liquidity. Is this something that's obvious? I mean, if you think about the general trend of the design where you have multiple layer ones, you have dApps that want to be built on these. You mentioned Web 2 experiences are better than Web 3 for sure. So it's like when you think about what you're building, do you think about it as like, yeah, this is just the next brick we have to build in this road towards a great user experience?
I do, yeah. That's always,
Yeah.
kind of how I think, because I think at the end of the day, like, you have to go back and like understand like what are the core features that we offer with Web3 compared to Web2, right? And you have strong composability, you have strong distribution channels that you can have in Web2, and you can also make the developer lives a lot easier in Web3 by having the blockchain. It's actually, I believe it's going to be easier to build on a blockchain in years from now than it is to build like a traditional Web2 a Web2 application, right? But yeah, that's the goal. How do we get there? What are the building blocks that we need to enable along the way?
Yeah, I heard some stat recently. The number of blockchain developers is somewhere in the order of like 7,000 full-time, whereas the number of full-time Web2 developers is somewhere in the order of like, I think it was like 20 million. It was just a dramatic difference.
Yeah, I don't think it's 7,000.
That was somebody else, but
I think I saw like numbers, maybe like some people say 20 to 30,000. Some stats say like even close to like 100,000. But yeah, like very big gap still.
Still relatively small. Interesting. And when you think about growth, when you think about growing Axelar, what are the key pillars? Is it integration to other chains or validators or user? Like, what's the growth OKR?
Yeah. I mean, number of integrations that we support, definitely, right, is one of the metrics. And then two, just the amount of kind of a application / cross-chain interactions that we enable, right? So if you have an application that goes live, if it has cross-chain enabled underneath it, then users get to benefit from it right away, right? And kind of see the new experience. Kind of as a sample, I think we launched the network about 4.5 months ago, and we did like over $1 billion in cross-chain volume, right? We did like 200,000 or probably more kind of a cross-chain transactions. So yeah, definitely kind of just understanding what those metrics, understanding from which blockchain to which other blockchain people go, how much traffic goes there, is that what we kind of look at when we think about growth.
And what are the main pipelines? Like, is there anything that would surprise me, or am I thinking like Bitcoin to Ethereum and vice versa to USDC, or how does that look?
A lot of the pipelines have been between Cosmos and EVM chains, right? Which was kind of our initial go to market. Initially, we onboarded like a bunch of different Cosmos chains. We saw a lot of traffic from Terra, for instance, in the early days, right, when they were trying to distribute their stable coin, across multiple EVM chains. Then we announced an integration with Osmosis, and then Osmosis was driving a lot of liquidity in. So we saw a lot of traffic from Ethereum in particular, and from like Cosmos, from Polkadot to Cosmos and to Osmosis to participate in the DEX. Now we recently announced more integrations between Polkadot and like Moonbeam and Osmosis as well. So we're starting to see more activity there, going back and forth. So I would say it's kind of it really. We try to help as many projects as we can, right? It is a little bit also on their roadmap to see how aggressively they grow, right? And so if some of them, when the integration goes live, they're like, okay, let us throw a lot of incentives, right, to our developers to start building on us, and then we definitely see kind of a more activity. So I would actually say that probably the activity through Axelar is actually a good indicator of which ecosystems, doing a lot of kind of aggressive go-to-market or, developer incentives to kind of attract the build-outs. Because at the end of the day, every developer needs this liquidity composability, right? The only question is like, how do they get that, and what is the shortest path to get there?
So when you think about Axelar as being an indicator for what projects are, do you think of it as specifically what projects are incentivizing growth by like airdrops and those kind of things, or like what you're looking at volume of liquidity between different protocols, right? So how would you parse that out into like not necessarily predicting it for investing, but just as predicting it to understand what's happening in the network?
Yeah. So first, just to clarify, we don't necessarily look at like the volume across chains, right? So by Axelar, we also support things like general message passing, right? Which is an incredibly powerful paradigm. And, I encourage people to kind of spend some time and read more into it. But effectively, liquidity transfer as a concept, I think, is not going to be, as important as people have thought about it in the first, instances of cross-chain activity. You don't necessarily have to move liquidity. Yeah.
Can you say that name again? I want to make sure I got that.
Yeah, it's general message passing.
Oh, right. General message passing?
That's right, yeah. So,
gotcha, okay.
Like, just to give you, kind of a 2 cents, what it means, kind of traditionally, right, when people thought about cross-chain activity, they think about moving tokens, right, from one chain to another, which is great, but you move in tokens to use an application, okay? Now, with general message passing, you don't actually have to move tokens. You can take your computation or your program and move that to where the tokens are to do some functions on it and then return the result back to your home chain, for instance, right? So that's what these are the things that enable these types of super seamless experiences where, imagine as a user, you have a simple, activity that you want to do. You want to swap ETH for AvaX, right? Ethereum coin for Avalanche coin. Traditionally you had to do it by taking multiple steps and maybe, bridging something in the middle, going through some front end, flipping your wallet, using AMM on one chain, using AMM on another chain, and then, you end up with, AvaX at the end of the day. But you can actually program all of these human steps in a message and say, I want to do X, then I want to do Y, and then I want to do Z. But for a user, they don't have to flip between multiple wallets. They don't have to flip between multiple front ends to move the tokens, to use multiple dexes. So all of that gets programmed as a message that gets relayed and then executed, and then you just get the result at the end of the day. So very, very simple, right? So this is the concept of general message passing, which is incredibly powerful notion. And so that's going to enable very new generation of applications being built. And so there, you don't necessarily have to move liquidity. Okay, you can actually automate a lot of the steps. You can synchronize programs with one another, right? And you can synchronize user actions. So when we say kind of a developer activity in these ecosystems, it's not just, do I do airdrops or do I do financial incentives, but like, what are the developer programs that you have to allow your developers to build cross-chain applications, right? I think as an example, Moonbeam is doing a lot of work right now, in hackathons and other programs to say to their developers, you can build on Moonbeam and like through Axelar and XCMP within the Polkadot, you get all this connectivity, right? And you get all these building blocks, and this is how your application should look like. This is how the traffic would look like. So it's a lot of like developer activity, a lot of bootstrapping of that, is also, you can see like who's doing more.
It's super interesting. This general message passing, is this widespread? Like if I'm your average like crypto user, am I benefiting from this technology under the hood today, or is this still in the early days? And when it rolls out, it'll be a significant user experience change?
You probably not benefiting it yet. You will probably be benefiting it, in the coming months or coming years, and it's going to be revolutionary for your experience as a user. Seriously,
really?
Right? Because like I said, right, like the experience of interacting with multiple blockchains and multiple wallets and multiple AMMs to do a simple function today is just painful, right? Like, it's many clicks, gas fees across multiple chains. You have to think about it. And again, these things like general message passing then allow you to automate these things, right? So I guess like another analogy I like to think about is that, bridging and all that stuff, what effectively we have done is we have turned kind of humans into manual routers, right? So you say, I go from A, I go to B, and then I go to C, and then I go to D, all because I want to use these 3 different applications. So because none of that could be programmed, okay, in all of those bridges and like all of those like first generation solutions. And now you can automate all of that, right? And you can say, okay, you want to do A, B, and C. Well, you don't have to be a human router. That actually can be done by computers now. So, these are types of things that should have been done years ago, but, I think we're doing them now.
Yeah. Yeah, everyone's too busy building DeFi projects or CeFi project. Is this specific, like general message passing technology? This moving from like a manual router by analogy system to this automated system. Is this what was part of the catalyst for the raise and why investors got excited, or is it like maybe fill me in a little bit on what was the compelling narrative that it was part of the raise recently?
Yeah. I mean, I would say, definitely one of those things, but I think for investors in general, right, they're looking at like, what is the infrastructure, right, that's going to be key enabler to continue making progress in this space, right? And I think interoperability infrastructure in general is incredibly far behind. And I think, we're laying down a lot of the pioneering work to build that out. General message passing is, revolutionary. By the way, it's only one of the things we're doing, right? Like there's a lot of other infrastructure pieces, like services we're building along the way to enable those experiences, right? At the end of the day. So yeah, I would say it's a kind of a combination of, overall kind of infrastructure block that we're building, or multiple blocks.
Yeah. And does the timing of the market, or maybe how does the timing of the market affect you? I mean, recently we're now recording July 22nd, 2022. We've kind of been through a pretty volatile period of ups and downs with crypto and NFT, more specifically like the DeFi, CeFi craziness with Celsius is just kind of like maybe a month or two out. NFTs seem to have gone through like a wild, volatile up and down. Do you have a longer term perspective on this and maybe what's next, or how do you make sense of what's happening?
Yeah. I mean, market, I would say, affects everybody, right? And connectivity on different chains, affected us, of course, in many different ways. I would say when we were actually starting out, the project, people didn't even understand that there's going to be a need for cross-chain or multi-chain activity, right? People thought about like those token bridges and things like that, maybe as one-off, like ad hoc things that you need to do today, but tomorrow, those are not needed. And then like last year, sorry.
Take your time. It's the beauty of the long-form conversations.
Yeah, and then I would say like last year, kind of the market really changed, right? Where you've seen a lot of different chains, you've seen like a lot of different activity, and people like need this technology, right away. All of a sudden, we found a lot of pull from the market to understand, could you integrate this protocol? Could you integrate this network, and so on and so forth? I would say like over the last year, that has just been growing and growing, right? And now more recently, you've seen like yet another generation of different chains starting to enter, everything from like Avalanche subnets to, Polygon, like supernets, multi-chain strategies. You have, like Miston, you have like Aptos, right? With like Facebook and like new programming languages kind of coming up. And so the need for connectivity across all of those ecosystems, is just going to continue, I would say, growing and growing. I would say like overall, I would say like it's pretty healthy pause for the market to take a little bit of a breathing time and like build some of the core infrastructure that was not present, in the last bull run, that was a result of a lot of, bad experiences and things like that, right? Because even, with CeFi and like some of the other, solutions that we've seen in the market, a lot of them end up being centralized because those applications need to interact with multiple chains, right? And they depend on like multiple tokens. They depend on, having users from Bitcoin and from Ethereum and from Avalanche using their products, right? That's the only way you could build those applications before. Now with, general message passing and interoperability stacks, you can build all of those applications, but now finally in a decentralized environment, right? Across multiple multiple blockchains. And so that's why I'm like super positive actually that, we are in this sort of slight pause where people can understand, okay, this is the need of interoperability. Now, next time I won't have to go to, a centralized protocol. I have a decentralized protocol that I can look at, I can inspect, I can take, my own risks, and it would still have the same distribution as a centralized protocol and maybe the same UX, right? Which again was not the case in the last cycle, where all the centralized protocols had much better UX and much better distribution. So that's what we're trying to bring in now to the ecosystem.
Interesting. Do you feel like the I don't want to call it the collapse, but it kind of was of like CeFi networks or companies like Celsius was part of that in some way due to the constraint of what they had, what protocols they could integrate with or interoperate with? Like you said something there that was kind of, I wanted to elaborate on that a little bit more. Like, they have to have this centralized because they're like, what are they doing that they need to have the coin centralized?
Yeah, I mean, they were centralized because they needed to, they wanted to enable their product for users across multiple blockchains, right? So, like Celsius, right? Like, you could deposit Bitcoin and you could deposit, like ETH token, and you can deposit a stable coin and so on and so forth, right? So the tokens that they were listed in the part of their application were from multiple different blockchains, right? So how do you glue them together? Without interoperability protocols, you have to have a Web 2 product that's sort of gluing all these things together, right? And so they really could not build their businesses in a decentralized way. Even, some people say, could you do something like that? But the answer is no, you could not build something like that with the infrastructure that we had, right, 2 years ago. But now you will be able to do this. So you'll be able to build similar types of experiences and products that interact with tokens from multiple chains, right? But in a decentralized and open system.
Okay. So then do you see existing companies like BlockFi? I don't know what will happen with Celsius, but Nexo is another company in the space that seems very reputable. Do you see them re-architecting their backend to move in this direction, like integrating something like Axelar to have a more decentralized backend? I don't think they've said anything about that, but maybe it's just too early. But do you see that as the inevitability?
I mean, they either have to do it or other players will be built that would have, these decentralized backends and have, more trust properties for the users, right? I think with this, with this collapse, if nothing else, then reputation, right? And like understanding from a user's what's going on and understanding how those systems function is now questioned. And so, one of the answers to that is having a system that you can inspect and audit. And that means building, parts of the system or, on an open ledger environment where people can understand like how your system actually functions. So either they transition there or you'll have other projects that are doing same things, but in a much more trustworthy way.
Yeah. And then I imagine the only change would be key management. Like one of the things that seemed to be valuable for those companies was, hey, if you do lose your key, you could think of it as a bank. Okay, I forgot my password to the bank. I reset the password. They maintain the vault, so to speak. Do you see that as something that would necessarily change, or do you see also a middle ground for like key storage? With the popular phrase is like, not your keys, not your coin. But I've heard a couple different mechanisms for how that could be like shared risk, or I don't know if you have thoughts on how that plays out.
Yeah, I mean, great question, right? I think what we're going to start seeing is the next generation of like key management that sort of works in a hybrid model, right? Where, by default, like you're the owner, but maybe there is some type of a multi-party recovery protocol in case you lose your key, right? Where, nobody individually can kind of go and take your funds, but, you go to like a blockchain or a smart contract and say, well, I lost, my key and like I need to recover it. And maybe you provide some type of a proof. Maybe there's like some component that, verifies some of your claims. And then, kind of a multi-party protocol can kind of help you recover in one way or another, right? So I do see kind of some of these hybrids where, yeah, by default, we do need to enable, users to have ownership, to have, strong security, simple, interactions, and maybe you have some type of a recovery mechanism at the same time. I think another thing to note there, right? Like I think things like hardware, enclaves or processors that we're seeing now are going to be a big factor to enable some of this better key management, right? Which is not really done today, but I do think that will start happening more and more.
Hardware enclaves like a ledger where you have a USB to store the key versus.
So ledger is hardware, device, right? That's, physically detached and so on and so forth. But a lot of modern processors, including like Intel, including like Apple processors, they have their own small piece of hardware that you can use to securely store cryptographic keys. Okay. Things like that, maybe they were not as common, 3-4 years ago. Now they're becoming more and more common, where probably every, Intel-based computer that you have, it has this type of actually, special hardware instruction that's specifically designed to manage keys in a secure environment, right? That's not something that's leveraged today, but I do think it's going to, some people have started to leverage it, but I think it's going to be leveraged more and more, and definitely should be.
Yeah. One thing I've thought about is, I don't know if you've seen any companies doing this, but I've always thought when people die, say you do have your coins stored in a vault, literally a safe in your house, and you die, and like there's always there seems to be like somehow if somebody has access to it, you need like a middleman for this, right? To like verify, okay, Mike is dead, and we need to transfer his keys to his wife or whoever else is in the will. Have you seen any kind of like on-chain will contract or on-chain mechanism for disbursement of funds in the event that people die, which I imagine has to be like, we have to think about this, right? Otherwise there's just like a deterioration in the volume of coins and people get upset.
I mean, I have not seen anything like this. I mean, I would love to, get.
Doesn't it make sense? I mean, if you think about it from your own, I mean, how does everyone not have to have this in place to some extent? Like if no one else has access to, say, Sergey's keys, you have Bitcoin and some decentralized wallet, you store the key in a ledger, you have it in your safe, whatever your mechanism is. If you're storing it yourself, then you walk outside and a gorilla comes and tears you apart. You want to have that wealth transfer enabled. Like if you go to the bank will say, I'm sure the banks have a process for this already because they manage the funds. But I've always thought that there has to be some system for this. I don't know.
Yeah,
a random thought.
100% agree. Right? Like, yeah, I don't think anybody has thought that far yet.
Yeah. Are there other products or things in the market that you feel like are early to grow? I know, NFTs come in all shapes and sizes with varying levels of speculation behind them. Are there other conceptual frameworks around Web3? Balaji is put out aggressively a bunch of podcasts and his book with the network state looking at community as the next purpose for cryptocurrency and Web3. Are there areas like this that you're excited about or feel pretty bullish on?
Yeah, I mean, I would say kind of a lot of traditional types of businesses, right, that have struggled or could not be done in a reliable, trustworthy, verifiable way. Probably sooner or later, we're going to find their way building behind a blockchain stack, right? Even examples like, social media companies, right? Like, definitely a lot of talk about Twitter, right? And recently, like, and I think one of the things that like Elon Musk kept on saying during his offer is like, we need to open source like the algorithms. We need to people on, look behind the scenes, what's going on, how the system actually works, right? Things like, Facebook, again, like, it's all closed. So I think a lot of traditional companies that are probably finding themselves struggling to obtain trust from their users in a longer term, I think we're gonna start seeing rebuilding their stacks, and their backend based on blockchain technology. So still early, I think, but that's what I'm mostly I'm super excited about.
Well, I wonder because open source software is so prevalent and widely accepted that I'm wondering why haven't we seen more open sourcing of the underlying algorithms, especially behind social media companies that receive so much cultural and political pressure that I would think the simple answer to your point is like, okay, like I don't want to go to any more depositions by senators and congressmen. Like, let's just show you what's happening behind the scenes. Is that do you view it as like it's just difficult for them to do technically? Does it expose them to security vulnerabilities, or is it just changing culture is hard, or some combination of those?
Probably all of that, right? Technically nothing kind of a groundbreaking there, but of course, if you have multiple pieces of infrastructure, right? Maybe using like cloud components, maybe using some databases, right? Using some algorithms in the middle. You can open source bits and pieces for somebody to understand how it all stitches together, how it all functions. Probably not that easy. It's just all going to be like spread out across multiple, components. And definitely, they would have to do very thoughtful about, not revealing any secrets or any, proprietary information, things like that. The other thing is that because a lot of the code is actually written, I'm not going to say every company, but some companies is written as like partnership, right? Maybe it's a collaboration. Maybe it's actually a service that this company was doing to another company, or vice versa. Somebody else was performing a services to write these pieces of code, right? So just kind of figuring out legally, like, could you actually open source this piece of code or not? Let's go through our legal team. Let's figure out what are the dependencies, what are the, different code components we have used, and kind of going through that. So I think, like, if you have not started with that, like, you're gonna have to just do a lot of work, which I think might as well spend $100 million just building your software on a decentralized stack to begin with.
Yeah, totally. I want to ask you a little bit about the structure of the company. So you guys raised is the company is it set up as a company LLC or a C corp where you have shares in the company traditionally? Is it I couldn't find, but maybe I missed it, a token out there. Generally, projects will have a C corp. They'll raise for that, and then sometimes there's an agreement to allocate tokens pre-launch or post-launch for investors. I like to understand because different projects do it in different combinations of ways. But curious to hear your thoughts on how the organization is structured and how it might change in the future.
Yeah, kind of a lot of development is done, through a sort of traditional, right, like company. The token and other aspects of it, they're managed by a separate, there's Axelar Foundation, right, that's sort of responsible for the token issuance and kind of governance of that. And the network itself based on proof of stake blockchain technology, right? So kind of the foundation is managing and figuring out how to create like a healthy ecosystem around that. And then we at the kind of corporate side are focused on the kind of software technology build out.
And the foundation most of the same people on the company side? Like, would you be running the foundation in a different tab on the screen, or like practically what does that collaboration look like?
Foundation is a separate entity. It has its own, board, and it has its own, kind of a processes behind them.
Mm-hmm. And are the people on the board, is all that transparent, or is some of that like, I assume it would be?
It is transparent, right? I think, they have their own, website, Axelar.foundation, right? And they have their own sort of process behind that as well.
And so you're running Axelar, the development, would you call it a development company? Yeah. And when you say they, are you not a part of the foundation at all?
I'm not a part of the foundation, no.
Oh, okay. I would think you would be. Is that, given that you're leading development of Axelar, who runs the foundation, and what kind of credibility would they have, and why wouldn't you be a part of that?
I focus on the technology right now, right? There's, various kind of token pieces that have to be focused on to kind of figure out how do you create, a long sort of ecosystem. So it's just kind of a different goals, right? I would say. I think you see it really in the ecosystems project overall, where you actually have very different needs, right? Depending on what you're trying to do. You have kind of a software that you need to build. You have a lot of tooling work that needs to be done, right? A lot of infrastructure with partners that needs to be done. So, kind of as an example, we have various partners that are like, performing validation on the network, right? And we have validators that are open to that. And so how do you make sure that they are kind of maintaining the ecosystem, right, in a healthy way, and continue kind of running it? It's not necessarily the same thing as, kind of building some of the stack, and some other parts of the stack need to be built by other, entities again, right? So as an example, we had a lot of tooling that was done like externally for like monitoring. So for instance, Metrica, right, did Blockchain Explorer to help people understand like, okay, this is the state of the network. These are various alerts on the network and so on and so forth. And so, yeah, just kind of managing a lot of like the, ecosystem aspects of, of the project is, is definitely quite important.
So would you think of it more broadly as like the technical team is on Axelar development team side, and then the economics is on the other side? We're thinking about like proper allocation of incentives for validators, et cetera, and that's voted on by a DAO, or is that just a group of people on a board sort of making a decision?
I would say, yeah, kind of a ecosystem / external, right, activities is done through the foundation, and the ecosystem, not just economic decisions, but like I said, it could be, technical partnerships / collaborations, right, with other projects that, may need to be done to kind of grow the Axelar ecosystem, and Axelar kind of a corporate entity is one of the, contributors to that ecosystem.
Interesting. Do you feel good about it? Do you feel like this is the end game for the structure, having projects that are raised through like a development company, and then because the development company is not where the investors are going to make money, right? Or like you're not going to sell the development shop one day for $100 million. They're thinking about like from an investor standpoint, what's the mechanism for return on that investment?
Yeah, I mean, most of the investments, right? I think if you look at, they have a part of like tokens or that were, allocated, right, to them, and for the most part, it's a governance token used to kind of protect the network, right, to pay various like transaction fees on the network, and just to secure and sort of provide utility through participation of the of the token. I think, specific mechanics, I think will have to be kind of worked out as the project continues to mature.
Gotcha. Okay. So they put in 35 million and they get tokens and their governance tokens, as well as tokens that they would sell one day, and that would generate the return. It's like, in a simple version, that's how the investor structured the investment.
Yeah.
Interesting. Okay, cool. Yeah, I just want to understand it. I find it interesting, and I like to pry in and hear what works, what doesn't, what you learned. Awesome, Sergey. Where are you online? Are you tweeting, writing, any blogs or personal social handles you want to throw out there?
Yeah, kind of for Axelar itself, it's Axelar Core Twitter handle, right? For myself, it's Sergey_NOG. You can follow me there, and I can find like links to various kind of Medium places from there.
Have you written, or are you writing on Medium still?
I used to write more on Medium. Now I think a lot of or some of the writing that I'm doing just goes directly like on Axelar kind of website, so in the blog section. Sure.
Well, congrats on all the progress, man. It sounds like you're really working on a really important piece of infrastructure for the entire world. So I hope you guys keep crushing it. And thanks for hopping on today. Appreciate your time.
Awesome. No, thanks for having me.